Okay, first one I don't know because I don't know the definition of it yet. Second one I'm pretty sure I know how to do it. Quad this is week 81 of the Perl Weekly Challenge. This time round, well, let's just see what happens. Common bass string, task number 1. We're giving 2 strings, which we're going to represent in APL as character vectors. Find the common bass strings. A substring is called a bass string. If repeated concatenation results in the string. So I guess you need to find the shortest unique thing like that. A B C A B C A B C. So what I'm thinking, we take the unique elements and match them up. Then we get a thing like this. Scan that. Then we get a pretty predictable pattern like this. But what does this mean? Nothing. I mean, well, this one doesn't have it, and it still produces. So this is a nonsense. I've just written bullshit. Okay. First bit. Really? I'm not sure. I was thinking something like the common substring will produce some unique repeating pattern like this that I could usefully use. Or maybe I still can. Maybe I should disregard such a scan like that. The index of the unique. But of course it's not always the case that it'll necessarily be unique. Alright, let's undo this line of thinking. Okay, so my sort of gut instinct, which I've resisted to try and explore something that could be better, is, I don't know, somehow start from taking successive, literally brute force it, take the A, try concatenating A's. If that doesn't work, take AB, try concatenating AB's if we don't get far, ABC, and you just keep doing it like that. Seems very inefficient. And also, so ABCB, ABCB, ACB. And yeah, this idea of matching the unique, they are misguided, because obviously you can have a repeating bass string that isn't all made out of unique characters, so I'm going to disregard that. But yeah, the idea is you just take the first one, concatenate with itself. Yeah. So do alpha gets 1. Concatenate the self like that, and make self power 2. Oh, that's the problem, is it? It's sort of maybe. Oh, that is doing what I want. So, oh no, because it's going AB. Yeah, no. It increases in its size in powers of 2 when you do it this way, so that's no good. Could start with saying the base is alpha take omega, and then base, comma, be complicated this way of thinking. The thinking is, you start from 1, you take 1 character, then you start from 1 repetition, and if that matches the first 2, then you repeat again, and you keep going until you see if it matches the whole string. If it never matches the whole string, then we take 2 letters, and then we do that. And that just sounds like a horrible, expensive loop thing. Finding substrings should be easier. If we do enclose stencil like this, well, let's just back 2, 2. I don't want to type that again. No, you do have to parenthesize the operand, and you have to do a top right tab. Alright, so it's still a bit brute forcey, but the idea here is that if we increase this window size, we just increment it, at some point all the windows should match. We increment until all the windows match, or the window size is larger than the whole string. So what's this? Alpha gets, you start with right tack stencil, and then we could do like a rank 1 right tack. Oh, because the frames don't match. That's as if it is you. We just want if they're all the same, which I can cheat a little and go to Apple Cart, see if it's in there. Are all major cells identical? Oh yeah, if 1 is the count of unique. 1 is greater than or equal to the... If it was true, then we would, of course, take the result and just put that, and just output the result. Is there a thing about none? I guess we just return Zilda. In that case, ABC, B, ABC, B, ABC, B. In fact, if we table alpha at the outset, then we don't. And can we get like a quad gets here in each case? The padding. The dang padding. 1 drop, neg 1 drop. The last ones, he says. And that's exactly what we care about. How do we get around this? So from a stencil size of 3 or more, the beginning and end pieces get padded. with a space. Can we pad omega with spaces? Say pick alpha space taken by neg1 plus pick alpha. So, sorry, if our stencil length is 4 chunks, which would be the ABCB, it's padded with 1 space on the left, we're going to add an extra 3 spaces, which means the first chunk would just consist of 4 spaces, hopefully. And then it should move on to the actual beginning that we want. So that's spaces, comma, omega, well, it's left tack, comma, swap, I think. There it is, you see, spaces, and then it's ABCB, ABCB, ABCB. So there you go, that's the solution. With text descriptions in a moment. Probably just save it for now, but first let's just check with test cases. ABC, ABCD, CD. Oh, common substrings of both. Alright, I've just found in one. Read the question. Although having said that, I mean, or I would like counterexamples to really, oh, it could be any amount, so you don't just stop when you reach the first one. I made really any improvements to this are just about implementing better search algorithms, which I don't really know much about. Okay, what I'm going to do is save this one, go on to the next one, and then come back and pop it there. I mean, at the very least, we have a function that finds the shortest base string. We have a function which finds the shortest base string, and we can probably modify it quite easily in a minute to find all base strings, and then just return the common ones, I guess. Which again is pretty brute forcey, but yeah, let's come back to it. Because I think this one should write a script to find the frequency of all the words. Print the result as the first column. Each line should be the frequency of the word, followed by all the words of that frequency in lexicographical. No punctuation. Okay, it's like key, but we swap it around. For the sake of this, it doesn't have any specifics about the file. Like you assume it's just text. Could go to the effort of reading a text file in. Should we do that? Why not? Paste the text in. Save it under Perl Weekly 81 westsidestory.txt. So we live here, then we're building a function frequency sort. And if we're dealing with files, and I want to make it a tradfun f path. You don't have to, it's just a bit more sensible. Text get pick quad and get. And we'll see how far we get from there. It's called westsidestory.txt. Now we have our text read in with embedded new lines, which is why it looks funny on here. And then basically the way you do this in APL is you want to split words by space. We're going to assume the spaces, or we might want new lines. Same sort of result as the example. And you can see here that splitting by spaces splits the words nicely, but the new lines are a problem, so we'll have to include those. And we want to just remove the punctuation as stated. So we can do text without all of those characters, comma, apostrophe s, like that. Okay, well that's its own sort of thing. And what's dash dash? Okay, so we've still got apostrophe s. I'm trying to think. Well, if we just get rid of that, sorts that out. Okay, so we've removed all the punctuation now, and we're still splitting by spaces, but we need to split by more delimiters. So it's actually a space and quad UCS 10 and 13, which are the new line characters, and then we modify this from not equals to not member swap. And now it works with multiple delimiters. So this is our collection of words as a nested vector of simple character vectors. That's in there. Words gets this. Okay, so now we have all of our words. Here's 10 of them. And then we can do things like alpha and count omega key words. So this takes each individual word and gives you the word in the count. Of course, what we want is the other way round. We want the counts and then all the words that belong to that count. So we can take all the counts and use those counts as the keys into the key of the words. Does that not work? Length error. Oh, because that's the count of the unique words, whereas words is all the words. Okay, so that's not quite how you do it. It's the kind of idea we're going for. That would be easiest in terms of coding. Probably not very good in terms of performance, not very idiomatic either. We can look at this matrix again, the old unique words versus their relative positions. We make it prints wider. You can see like all the unique ones along the leading diagonal, but with some duplicates along the way. And what are you supposed to do with this thing again? If you count, this way round, you count across, and you'll notice that the number of rows is the number of unique words, but the number of columns is the number of total words. If we count down, then this gives us one for each quarter, this just gives you the counts you had before. That same shape, 103. You want these numbers, but you want them distributed along the regular words. Am I thinking of this the wrong way around as well? I mean, we'll take your thing from before, the alpha and the count omega keywords, and this time basically, no, because you group them by their count. Key kind of does. I think this is the way to do it. So if you take just the words and you do words index of them, that tells you where they first appear, not every place. Count of each unique word. You basically want to create a vector with the same length as words. You don't need to do any other clever crap. Take this guy, take the second column, and use it to group. Oh, whoa. The first one's there we go. Right. And then in lexicographical order. So really it's omega, comma, by the grade of it. And we don't, what? Oh, there we are. Bernardo's, but because we're ignoring apostrophe s, not just removing s. Is that some regex like dealy? I mean, we could pre-process the text like that with regex. So instead of our first thing with words, what we want to do is take escaped, that thing, these special characters. I think they are. Comma is fine. Apostrophe needs to be double. Oh no, that's a thing. And a dash is fine. Replace with nothing in the text. Ugh. Oh, it's any of these, right? Do you have to do those individually then? Or you can do them as a group. Dot. Yeah, okay. Dot, apostrophes, parens, comma. Everything in that group goes away. Not sure how I deal with the capital T. Oh no. No it doesn't. It doesn't distinguish that. So anyway, so the words are split. Okay. Now our words are a bit better. Now we can go back to where we were with this thing. W1 is the unique of omega. Considering we had to do a key to get this part anyway. So the key is alpha count omega comma over include omega index. Can you do a right? No, okay, because right tag's a function, not a reference. Alpha and omega sort omega key 1. And do it size that, let's find out what we do. So just parenthesize one of these guys. What? I thought we got rid of riffs in the text. Or was I referencing the wrong? Who were in the riff? Oh no. Okay, that didn't work. 150 drop. That guy. Led by riff. Neither can coexist with any but when riff 30 there. Okay, so we see the word riff. Is this a non-word character? Oh, word character, one or more. Replace with an. That's who? Yeah, it's the whole thing. Are you supposed to just remove the last? Reject max set last character. $1? No. Oh, that's replace, sorry. But then find it, drop that. That's not right. Yeah, that's 2. What are we talking about? Yeah. I don't want to match all the next one. I want to replace only the last. Reject, replace last 2 characters. Welcome to the portion of this where I'm just Googling stuff. Yeah, but that's the whole string. Oh, can we do it instead as apostrophe s and then a word boundary? We're just going to ignore the word bit. Yep, I'm going to replace that with nothing. Okay. So let's go back in time. So we had both. And we literally just get rid of the word bit. So it's apostrophe s followed by a word boundary. Replace with. Okay, we did it. Oh my god. Okay, copy this. There. Back to the challenge. So the words are right. I guess they're just not that bothered about this format. And we need to sort the result as well. Which I think we can literally just do the sorting idiom omega index. Oh wait, close, grade omega, squad omega. Yep. And instead of just like that, we're going to do pick comma slash spaces. How to do it like this to do fit quickly. Left tack comma space comma right tack slash and word. That's them all in one box. You have to disclose the box. That's this pick tack comma space comma right tack. And now we don't even need. That's a shame because if they close that. And then table the result. The table after everything. Does it just want it as one big thing? So after. Oh no. What's your plan, huh? What are you thinking? The problem is solved. Just trying to decide how we want the format to default right now. Not doing to strand the numbers and the characters. It's not strict about the output. I think this. Yeah, I'm gonna say this is fine. So now we pop this at the bottom. This is the whole solution. We break some stuff up. Why not? Okay, we've got this. Let's do the formatting in a moment. Before we do that, I have to go back to common base string and fix this so that it now finds what all base strings, of which presumably there can't really be multiple. Like there's one base string for any repeating pattern. The difference with the first example is there's two things. ABCD, ABCD, ABCD. Yeah, okay, now I see how there can be multiple base strings. Base strings, if one base string is literally just the other base string concatenated with itself. Oops. So my current thing only finds the one. What we're thinking is on new lines, instead of just incrementing like this, conditionally, the other base string can only be some factor, some multiple of the first one. Oh yeah, that's one thing I didn't test, is it? Oh yeah. Yes I did. What do you mean? This returns nothing if there are none. Why does it return something? Alpha. Oh, if it reaches the end. What if it doesn't? Hurry up to R A C D D. Oh no, there's a big hole in my approach. Damn padding thing. A C D A not a common base. Why does it think it is? We got ABC, 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 ABC. Then you should have the base strings ABC, 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 ABC. Have those three. So let's start here. So if you do one take, do comma self omega map alpha to by length omega. If that was true, then we found one. Otherwise, we have not. We have found a base string. Otherwise, we have not. You will be alpha. Okay. Alpha will start as 1. We're going to do it this way because I'm a dum-dum. Anyway, so if that's Zilda, that means we didn't find one. Increment alpha and recurse. Otherwise, we did find one. Found a base string. What do you want to do with the base string? We want to see if we can duplicate the base string to find another base string. How does that work? Well, we do bs, comma over enclose, 2 times the length of that, curse, omega. And if alpha is length of omega and Zilda. What are the chances? I don't know. Don't know. Found one. Found ABC first. Hold on. Don't forget to quad gets BS. Oh, whoa. Well, that clearly doesn't work. Just gone into one giant loop of trash. Nothing. Oops. Oh yeah. Oh. Does that mean we found? No, it means we found a candidate for a base string. Really, what you need? That's not what you do. Oops. ABC. You take that length. 3. Reshape. 3. Take 1. 1 0 0. Then you do taken by length omega, count of omega, reshape by, then you do omega enclose by. Then this tells you if it's a substring, so unique. More like base string is alpha. Then if alpha is omega closed by base string reshape by alpha take 1, reshape by count omega. If that's true, then we have a base string. Otherwise, alpha plus 1 curse omega, alpha does equal the count of omega, then yeah, we're not finding it. And let's return alpha. Once we've returned alpha, we do want to... Oh, I see. I don't know, one taken by the length of alpha. Yes, match first. These, unique, mix. Yep, that's the clay. Then have base string, otherwise don't. Then if BS Zilda, then we don't have string that again, do, then let's turn that alongside 2 times the count. Now alpha, thing there, omega. Recurse omega. Oh my god. Okay. Let's start from the top and see how we go. This out, so starting from A, and omega is omega. We don't need this. No, the problem is we want to embed a conditional. This really isn't the way to implement this algorithm. Be used up and against. No base, we recurse. No base string, so we recurse. ABC. Really? Oops, let's go back. Step. See where my logic part. A, B, A, B, C. Huh? Oh, but alpha. What? Oh, sorry. Let's try again. Oh, in which case, it's really more like alpha. Alpha is 3. Alpha, we'll do that in a second. Start with 1 to alpha 1. Reshaped by count of omega. Omega like that. Partitioned by that, sorry. No. Mix the unique of that. Alpha 2, omega is that. Not true. The rank error. It's rank 1. Sure. Let's do that. But that's a single. Then not. There's more than one unique thing in there. That's gonna go with comma mix. There we go. Then yeah, and if that's the case, then be with alpha 2 omega, which is BS, which is the base string. Okay. Whoa. Generate the base string. Okay. Again. A. No result. Oh, because otherwise from Zilda. B. Return BS. Oh, sorry. One step out. BS, comma. Separate by a file. Oh, okay, it's done it, but maybe comma over enclose the one. Might just be comma then. And this quad gets in there that we don't want anymore. And concatenating strings don't work. BS, comma, enclose. What to do with the structure? Can I make that string comma enclose if simple? Nope. Comma over. Yeah, okay. Oh, and we've returned a Zilda. So what? -1 drop on the highest level. Does that work? No, of course not. Return. I don't know what. Enclose Zilda without swap. Yep. No empties. Right, finally. Okay, so we've written a thing that finds all the common base strings in almost the most brute force way. I mean, it's brute force up till the first base string, and then it's just doubling the length. And then the common base string requires an A and a B. So A, B, C, D, D. I'm not really convinced that my approach is the best for this problem at all. And what's your issue? Yeah, basically, find base string is a function which looks like this. It's a monadic function. Then what we have to do is find... does this work? Alpha union over find base string omega. So the idea is it finds the base strings of alpha and omega and then does the union between, and it requires a left argument, so A, B, C, D, E. And that's not right. Oh, maybe it's intersection. So this finds both of them. Well, that's the concatenating. Sorry, we want union. We want no, not really. I feel like either one. Find base string. Oh, because yeah. Okay, I think it's intersection. They don't currently intersect. Okay. Help if the right string, correct string has the right argument. So this only finds. Oh, it finds. Maybe it was union we wanted. I don't know. Find base strings alpha omega. It really is. Okay, it was the union all along. So A common base strings AA. Whew. That was more of a slog than maybe it should have been. Right, need T. So what I'm going to do now is go make T, go into Sublime Text, and take a look at these, maybe do some comments, and then wrap it up. So I'm going to pause the recording for now. 3. And Oh, and there's audio in, sorry. Okay, and we're back, and we're back, and we're back. Speed up, and all such and such. Okay, let's start with frequency sort. Conceptually quite straightforward. Also think for the sake of the comments, let's set these up a bit. So this is clean, then sort by number, sort by number. So, the idea is now, can make all the comments nice. So, read text file. If we want, we can get text. We can look at the documentation for quad in get with F1, and we can get the content encoding new line, text coding new line, and then we know what's going to be in there. It's always 10 or 13 or 10 and 13 for Windows. Anyone who knows about text processing will know about the new line fiasco. Okay. No punctuation or apostrophe S. Split words. What should we call it? Nested character vector of words. Nested vector of character vectors. We could clean this up by changing this into something with two things. Unique and count. And we'll just do alpha, count, omega. So this is frequency count of words. This means instead of doing key 1 and 2 like this, we're sorting unique words according to the count, or rather, group words by count and sort within this bit here. And lastly, sort output, sort by sort by count. Okay, cool. And then the base string, find base string. This is reach end of string, base string candidate. So this is really where all the logic happens. Substring is a base string. If no base string, increment substring length, try again. And this one's basically saying return base string and check superstring base strings. That's too obscure. Common base strings of alpha and check. Is there a word for if you catenate something with itself? Duplicate or is superstring, check a string, and check superstring, and comma selfie BS I think is enough for someone to figure this out if they were just reading it. Okay, so I'm pretty happy with that. Yeah, scroll up like that. And the other guy looks good. So, yep, finally, let's have one last talk through the two challenges. Much more involved for me than they have been in a while. Part of me thinks that's because my approaches aren't that good, even if the problems were solved. They're kind of these text processing things. Maybe this is something where Perl has and Raku have like a string type that does well. So maybe this is the sort of processing that can be done more elegantly with like an actual string type. Not that I particularly know. Probably worth investigating. Or I'd be happy to hear if anyone does know. Or I'll just look at other people's solutions next week in other languages. Because my approaches in both cases have been quite brute force. Frequency sort, since I looked at the title, I knew I was going to be using the key primitive operator. And then everything else was some pretty bog standard text processing stuff. So actually I'm quite happy with frequency sort. I don't think you can do that much better. Yeah, really. It's a single application of a very common key thing. Just find the count of each unique word. But then the extra trick was you needed to sort the words into their counts. Group words by count. Find base string was a bit of a struggle. And then I ended up going for what was my first instinct anyway. The idea that I'd start by taking one letter, duplicate that, two letter chunk, duplicate that, and see if it matches anything, and blah blah blah, and just do that until we find these substrings. So really, that's just an exercise in recursion. I'm trying to think if there's a more. I'm going to do one sign off now, and then I'm going to have a very small play, just to see if there's something. The problem, really, is that you're dealing with non-rectangular data structures. Alright, if you have arrays which are rectangular data structures, you can get just the best solutions directly with the primitives. Very short, one line usually. Boom, there you go. But when you have things like this, where you have different length things, you want to compare something this length to something of a different length, you end up reaching for the nested data structures, nested arrays, blah blah blah. Alright, thanks very much for watching, and see you on the next one. Okay, last little thing. ABC, ABC, ABC. The idea here is to take every and compare it to the other one. So it's count omega. Each of those, take omega, do alpha, omega take alpha on each of those. Oops. Omega take alpha. What? Alpha is omega. No, it is omega take alpha. What? Like this. I need a jot. There we go. Needed to bind it. Oh, that's pretty interesting. Right, anyway. And now, basically a matter of comparing each of these. Could we even mix that? Omega match rank 1? No. Omega E is very full. I was thinking of just counting them. Like literally summing them. Yeah, exactly. And of course, for the mix one, what space? Basically all the leading substrings. Then, and we did, to be fair, we had this bit. String is wasn't a very nice way of doing it. So you'll see where I'm going with this because I'm about to stop. But basically, it's the idea that you'd have all your base strings like this, and for each base string, take omega, you take the length of alpha 1 reshaped by omega. It's omega. Alpha is omega. Yes is alpha. Omega is omega. 1 to alpha. Yeah. Oh, sorry. That's fine. Do omega on the left. By that. There we go. Reshaped by length alpha. And it's alpha by. And it's E. And you can see that the ones which match strings, or the base strings rather. Yes, there we go. And then it's BS. Pressed by that. And we know that the last one is always going to be the entire string itself. So this is another. What's odd? No, it's not another. It's the same approach, but using eaches instead of this explicit incrementation. And the disadvantage here is that we're going to generate all of the substrings. The advantage here is if there is a substring, we'll stop when we get to that. So this first approach is fine. All right, I'm out. Bye.